Welcome to Roddy DIY Audio. Today, we are tackling one of the most controversial and fiercely debated topics in the entire audiophile community. Do AC power chords actually change the sound of your system? Is it real sonic reality or just a placebo effect? In this video, we will look at this from entry to high end, strip away the audio myths, and analyze the raw physics and time domain engineering behind the final meter of your power grid. The great audiophile debate. If you look across the audio world, you will see two extreme sides. One side argues that physics cannot prove it, claiming it is purely psychological and that standard power chords are more than enough. On the flip side, audiophiles experience an immediate jaw-dropping difference in dynamics, background blackness, and soundstage presentation the moment they swap a cable. To settle this dispute once and for all, we must look deeper than basic electrical theory and examine how power supplies interact with music in real time. Series agenda. In this theoretical breakdown, we will first reset our understanding of what amplification actually means. Then we will expose the violent physical interaction inside a dual-phase power supply, specifically looking at the charging and discharging phases. Finally, we will dissect the four electrical factors of a power cord: impedance, shielding, contact resistance, and dielectric properties, concluding with a comprehensive impact matrix. Let's look at the science. Principle of amplification. To understand why a power chord matters, we must first shatter a common misconception. Many people believe an amplifier takes a small music input and grows it bigger on its own. But in ideal electronic engineering, that is not how it works. An amplifier is actually a modulated faucet or valve. The music input signal only acts as a control mechanism, rapidly opening and closing a gate to allow current from your power supply to flow directly to your speakers. This means your music is literally made out of your power supply current. If your power supply is unstable or polluted, your music is instantly corrupted.
Two continuous phases. Inside every audio power supply, the energy delivery mechanism is split into two distinct alternating phases that loop continuously. Phase 1 is the charging phase, where current rushes from the wall outlet to pack energy into your filter capacitors. Phase 2 is the discharging phase, where the transformer cuts off and the circuit draws its energy directly from those storage capacitors to drive your music. The critical trap that most people miss happens during Phase 1, and this is where the behavior of your AC power cord dictates your sound. Phase 1, charging phase. Let's closely analyze Phase 1, the charging phase. This event occurs only when the alternating voltage from your transformer peaks higher than the remaining voltage stored in your C filter. At that exact split second, the rectifying diodes snap completely open. This forms a direct, physical current path running all the way from your AC wall outlet, through your power cord, through the transformer, and straight into your circuit. In this high current rushing moment, your power cord is a live part of the amplification path. Therefore, the electrical behavior of that power cord directly impacts the sonic character and purity of your audio. Phase 2, discharging phase. Now look at Phase 2, the discharging phase. When the input AC sine wave voltage drops below the capacitor's stored voltage, the rectifying diodes instantly snap shut, turning off completely. This process completely disconnects your amplifier circuit from the transformer and the AC power cord. During this quiet window, your audio circuit relies entirely on the energy stored inside the C filter. In this phase, the sonic signature is governed by the quality and speed of your capacitors, while your power cord rests until the next wave hits. Timing and ripple reality. These two phases do not happen slowly. For a standard 50 Hz mains frequency running through a full wave rectifier, this switching cycle hits your system exactly 100 times every single second. This creates a continuous 100 Hz ripple. Because human ears cannot separate a cycle that happens every 10 milliseconds, what we perceive as a continuous musical note is actually a fusion of these two phases. This proves scientifically that your AC power cord, transformer, and diodes form the very first stage that defines the foundation and cleanliness of your audio before passing the torch to your capacitors.
Now that we know your power cord is a direct part of the circuit 100 times a second, we must analyze its four key electrical factors. These are not imaginary properties. They are real, measurable variables found in any conductor. First is impedance, which includes both resistance and inductance. Second is shielding against electromagnetic interference. Third is contact resistance at the plug terminals.
And fourth are dielectric properties and stray capacitance of the insulation. Let's break down how each variable manipulates your sound. Factor 1. Impedance breakdown. Let's dissect factor number 1, impedance. Standard stock power cords are often thin, running around 0.75 square millimeters. In that violent split-second charging phase, this thin wire acts as a high-inductance bottleneck, behaving like a low-pass filter that severely slows down your current delivery speed. Upgrading to high-purity, thick conductors like OFC or OCC copper dramatically cuts down this internal resistance. OCC copper uses continuous casting to eliminate crystalline boundaries across a single meter, allowing current to flow seamlessly with zero harshness, delivering explosive bass slam and precise transient control. The hybrid cable flaw. Knowing this allows us to expose a popular marketing trap: cheap hybrid cables that bundle thin strands of copper and silver-plated wires into a single strand. Due to the skin effect, high frequencies ride exclusively on the outer silver plating, while low frequencies travel through the copper core. Because silver and copper have entirely different signal propagation speeds, this mismatched architecture triggers phase smearing. Your music timing gets distorted, flattening your soundstage and blurring your instrument separation. Professional manufacturers like Furutech avoid this by utilizing isolated, individually insulated cores to prevent phase distortion completely.
Factor 2. Shielding and near-field induction. Factor number 2 is shielding, and here is a massive realization. A 1 to 2 meter shield is not meant to clean up pollution from the power plant miles away. Its primary job is to fight near-field electromagnetic induction right behind your audio rack. An unshielded power cord acts as an antenna, picking up Wi-Fi and radio frequency garbage. More dangerously, during those heavy 100 Hz charging spikes, an unshielded cord radiates a strong magnetic field that crosstalks directly into nearby fragile analog cables. Utilizing foil shields blocks high-frequency RFI, while copper braid chokes low-frequency EMI, dropping your system's background noise down to dead silence. Factor 3. Contact resistance. Factor number 3 is contact resistance. If your wall plug or IEC connector fits loosely or is made from cheap materials, it creates an immense resistance node right at the junction. This bottleneck triggers severe voltage drops during current peaks. Upgrading to tight clamping plugs with specialized platings transforms your sound based on raw metallurgy. Gold plating offers immense long-term chemical stability with zero oxidation, creating a rich, warm, and organic tone. Rhodium plating provides exceptional physical hardness, scratching away micro-imperfections to deliver razor-sharp micro-details and pristine background quietness. Pure silver plating delivers the highest electrical conductivity on Earth, unlocking open dynamics and maximum speed. Factor 4. Dielectric and capacitance. Factor number 4 is dielectric absorption and stray capacitance into the wire. Standard PVC insulation has a very high dielectric constant. It sucks up energy and releases it slowly, causing severe phase shifts and a muddy, congested sound. Upgrading to PE, or the king of insulation, Teflon, ensures ultra-low absorption. This preserves exact signal timing and phase alignment, unlocking a holographic, three-dimensional soundstage where instruments are completely separated. Advanced designs even incorporate air tubes to maximize space, dropping stray capacitance down to near zero. The 4 factors matrix. To wrap up our theoretical analysis, look at this comprehensive behavioral matrix. As we have proven, every single material decision inside an AC power cord follows strict electrical engineering laws. Mismatched impedance deadens your dynamics. Poor shielding lets noise pollute your background. Weak contact resistance truncates your power delivery. And cheap insulation distorts your timing. In our next episode, we will transition into full hardware recommendations and share our specific matching charts for your power amplifiers and source gear. If this science-backed guide helped you, please hit the like button, subscribe, and share this video from DIYAudio. Thank you for watching, and see you in the next part.